Alrighty, thank you all for being here. Today, as said, I'll be working on or explaining a little bit of my work on the development of an electrodynamic dust shielding enabled brush. As introduced, my name is Kristoffer Sjolund. I am a PhD student at the Georgia Institute of Technology, and this work was advised by Dr. Micah Scheibel, Dr. Thomas Orlando, and Dr. Julie Lindsay. Over the course of this presentation, I will go over a bit of the existing work that started for the beginning of this project, some of the goals that we had on improving upon that existing work, the prototype that we developed from that, the results of that prototype, and then some of the things we would like to work on moving forward. So back in 2020 and 2021, there's a student team at Georgia Tech that I was a part of that wanted to develop a electrodynamic dust shielding enabled brush, or an EDS enabled brush. The goal of this was to improve upon the base functionality of brushing, which was one of the techniques that was used for the Apollo missions to try to clean off some dust, but was seen to be kind of weak. So we thought, well, let's see if we can incorporate EDS into that to make it work a little bit better. During that time, we were able to do a few experiments. The images for those are shown on this slide, where we had the EDS as a separate device that was inserted into the brush. We applied a two-phase EDS signal to that. And then we also had photoelectric charging with a UV excimer lamp to try to encourage some dust to move. And we were able to get some results there, but it was not an ideal situation for what we had in mind. So there are, again, a number of limitations on those experiments. Some of the main ones, it was a single row of electrodes inserted at an angle into the brush. And also we only had two-phase instead of three-phase EDS at that time. However, since then, our testing situation on campus has improved. So we've been able to improve that for moving forward. So in addition to that, we wanted to greatly improve the EDS operation for this device. And one of the main aspects of that was to actually have the EDS as part of the brush instead of as a separate device as shown on the last slide. In addition to having it being part of the brush, that would make for simpler operation instead of having to have two devices that we would send to the moon, to be one. And then also that gets us closer to our goal of being able to have a brush that has EDS working at the same time. So that would hopefully and theoretically improve the overall ability of the brush to clean a given surface. And I forgot to mention earlier, the goal for this of having an EDS brush is to clean surfaces that we can't easily incorporate either surface treatments or EDS into. So originally that was trying to clean the surface of spacesuits, but could be any other surface, making it easier so that we don't have to have expensive surface treatments put on everything. Maybe we can have this solution, or at least as this solution to stopgap until we are able to put special treated surfaces onto everything. In addition to the improvements of having EDS in the brush, I wanted to have multiple rows of electrodes throughout so we'd have proper coverage that the EDS could better clean all of the bristles, and also using the three-phase EDS system that we have developed to be able to have a better and more directed dust movement, so we could ensure that dust would hopefully go out of the bristles instead of just kind of move around the bristles and not cause much in terms of the way of cleaning. The image there shows one of the concepts that was generated during the Big Ideas Challenge. We wanted to have, again, the brush that astronauts could use for cleaning themselves, and some of the work that we did on trying to make that a better tool for astronauts. So for the prototype, the approach I had was just to do rapid iterations of the prototype, trying to see if I could get to something that would work better more quickly. So this is the image of that. I used prefabricated brushes that I cut down to fit better into this shape. It was nylon bristles, just using something that was simple, and that was nylon, I believe, was used for the Apollo missions. For the electrodes, I used bare copper wires we had in the lab. Again, the idea was just something that was easy to work with. So that was that part. The bracket for this was a PLA bracket, just because, again, the rapid prototyping nature of the project. And then there were various mounting points to put it into the vacuum chamber, and then to allow for the electrical connections. On the right side of the slide, there is the wiring configuration that shows how I was able to get the three-phase system into the brush. And then for that, we applied the signal with the EDS signal with three phases that are 120 degrees out of phase from each other. So we were able to put this into a vacuum chamber that we had on campus. We applied the dust in ambient conditions, as we didn't have a way to apply it in vacuum at that time. We then pumped the chamber down to about 10 to the -7 torr, trying to get close to lunar conditions. I know this is still a fair amount off in terms of pressure, but given some of the materials that we were using and the rapid prototyping nature of this, we wanted to have something that we can do that was in vacuum. And then the voltage that we applied was up to about 750 volts peak to peak with the Mosner-Higuchi waveform, which just goes, it's like a very, looking on the word, but it just goes from 0 volts to some positive voltage back to 0, then to that negative voltage, going back and forth again with the 120-degree phase, they're out of phase between the 3 different electrodes. So as you can see on the bottom left of the black and white images, we were able to get some cleaning about 1 millimeter away from the electrodes, which was very good, as we were happy that we got any positive results here. There was a worry that maybe nothing would quite occur with this. But as the electrodes themselves were spaced about 5 to 7 millimeters apart as a restriction of the rapid nature of the prototype, the overall coverage of the cleaning was not the best. So that's one of the things of moving forward. We need to see if we can get the electrodes much closer in order to have better overall operation. Additionally, one thing we did not expect that did occur was the EDS caused some of the bristles to vibrate, which allowed for more movement of the dust, which was another good thing that we could try to factor into our future designs. Also, for the system that we had for testing this, it was set up so that we could capture dust cleanliness of a 2-dimensional surface. And when you're trying to image down through bristles, as you can see, it gets very dark immediately as you get past the very tips of them. So we need to work on ways to improve measuring that. Part of that will be if we can move to a larger chamber once we have a better prototype, but we're still working on ideas for that. And if you have any, I would be very happy to hear them. And then also there were some shorting issues that we had due to the pre-manufactured brushes. So future work, and there's quite a lot of it that we need to do, wanting to work on improving the electrodes that we have. So having copper wires as the electrodes in a brush, the moment you try to brush on anything, they will get bent and they will stay bent. And as they were uncoated, they would short and it would be a mess. So we need to improve upon that. Some of the ideas that we have are using steel wires that are coated, because then they would have the greater elasticity that would kind of match that of the bristles, but then also pose another risk of, well, the steel wires could be kind of sharp. So we need to worry about that as well. We're also considering using carbon fiber as another type of conductive surface that could also be something of a bristle for us. For the experimental improvements as well, we want to see if we can get some dust depositing in vacuum. Some of the other presenters mentioned it is very important how you deposit dust onto your surfaces to see if it's more applicable. Also, as this is a brush, we want to see if we can test the effectiveness of it while it is brushing. We've been working on a setup for that. Unfortunately, was not able to get any good images to include in this presentation. We're getting closer and closer to having a moving brush in our vacuum chamber. And as I said earlier, working on alternate metrics to determine the effectiveness of the brush, whether that is a improved way of capturing images of it or having mass measurements or something else that we were able to do. And then lastly, we're looking to see other ways that we can expand EDS. I know I kind of brushed over this earlier, but EDS is traditionally for very flat surfaces or maybe some minor curvature to them. This brush is a very new form of that, so we're wondering if we can take this to other forms. This would greatly help with addressing other gaps of possible unanticipated situations that will occur with the Artemis missions, or just allow some ways to address the dust problems that will be on all of the moving things we have when we get to the moon and possibly to Mars. So with that, I want to thank Survey and then the Reveals node of that at Georgia Tech for working on this, as well as the Big Ideas Challenge that kind of got me and all this work started at Georgia Tech. And thank you all for listening to my presentation. And are there any questions?
We have time for one question.
Are you, do you have any concern about the safety of an astronaut applying high voltage to their spacesuit to clean themselves?
Yes, that is definitely one of the things we have been worried about on the depth of if the electric fields penetrate into the suit, or again any sparking or shortage. So that's one of the aspects where we've been moving a little bit away of having this being for cleaning the astronaut spacesuit versus other surfaces. But we are still trying to just get the brush working before we start addressing some of the other problems. It was one of my goals with this prototype, was just get functionality, and then I'll work on the other problems later on, as there were many in that prototype. Thank you.